Hello viewers, to another video of Smart Pathshala. Today we will learn to develop some formulas of derivative, or you can say of differentiation, right? Or the differentiation process. Now, if you have not watched the video of mine, the previous video, which was I represented the different way of representing the differentiation in geometrical and physical way, then click on the link, click on the I button over here. Then you will read to that video. First watch that video, then come to this video. It will be helpful for you. Now, let's start. Suppose we are given different polynomial functions. What polynomial functions? Now, generally, the polynomial function will have a term x to the power n, where n can be any number, right? Now, suppose you are being given a function f of x equal to x to the power n. Right? F of x equal to x to the power n. You are being given this function. Now you need to differentiate this function f of x with respect to x. So how do we write? In the previous video, we have learned about this thing. We write ddx of f of x is given by ddx of x to the power n. Now according to the definition, we will write limit h tends to 0 f of x plus h minus f of x by h, which means limit h tends to 0 h x plus h, which means x plus h whole to the power n minus x to the power n. This will give us limit h tends to 0 h. Now here, in this situation, we need to apply a thing called binomial theorem using binomial theorem. If we apply the binomial theorem, what we will get is that if you expand this term, this a plus b whole to the power n term, that is x plus h whole to the power n term, then you will get x to the power n at first, and then plus nc1 x to the power n minus 1 h plus nc2 x to the power n minus 2 and h square, like this dot dot dot, and at the end you will have h to the power n minus x to the power n. You can write it. Okay? Which means the value of x the power of x will gradually decrease and the power of h will gradually increase as you go to the further terms. Right? So x to the power n is over here. Now you can see, you can eliminate this x to the power n and this x to the power n. So after eliminating, what I have is this term. Now nc1, calculate nc1, will have n and x to the power n minus 1. h by h. Okay, let's not do this thing now. h will be over here, and then we will have nc2 x to the power n minus 2 h square plus dot 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 plus h to the power n. At this point, h is over here, right? Now, if I further simplify it, then h will be divide this whole term, and this will give us n x to the power n minus 1 plus nc2 x to the power n minus 2 into h plus dot 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 h to the power n minus 1. Now plug in the value of h, which is tending towards 0. Plug in that h is equal to 0. What I obtain is n into x to the power n minus 1, which is nothing but the ddx of x to the power n. Right? So you must note down this formula, because we need this formula in various cases, in derivating in many of the polynomial functions. Now, the one formula we got is ddx of x to the power n is equal to n x to the power n minus 1. Now, let us suppose f of x is equal to a constant, right? A constant term. F of x is equal to a constant. It does not change anyhow if you change, right? If you change x is equal to 2, 3, 4 for any value of x, the y value is a, that is constant. Now, how do we find the derivative of this term? That is f dash x. We can write f dash x as d dx of f of x, right? And this will be limit h tends to 0, f of x plus h minus f of x by h, which means it is limit h tends to 0, and this is a. The value of this one is also a, because this value of function is not going to change. So we have 0, which means we have another formula, d dx of a constant a is equal to 0, where a is constant. Now note all this formula down to your copy. Okay. Now let's find out another thing. Another formula. Number 3. Suppose we have another function f of x as sin x, one trigonometric function, right? Trigonometric function. Perfect. We can have is, now the thing is that we have to calculate f dash x. Now similarly, if we need to calculate f dash x, we can have limit h tends to 0, f of x plus h minus of f of x by h, which will give us limit h tends to 0, and f of x plus h means sine of x plus h minus sine of x by h, which will give you limit h tends to 0, h, so sine c minus sine d, 2 into cos x plus h plus x by 2, and sine of x plus h minus x by 2. Now this term will give you limit of h tends to 0. Remember, you can take this 2 in the denominator. How? Just divide it, numerator and denominator, by 2. Okay. Now you will have cos of 2x plus h by 2 into sine of h by 2. Now, according to the algebra of the limits, we can separate these terms, h tends to 0 and cos of 2x plus h by 2. Now this is will be multiplied by h tends to 0, sine of h by 2 and h by 2. Okay. Now if you plug in the value of h as 0 here, what you will get is cos x into. Now, if h is tending towards 0, then h by 2 is also tending towards 0, which means limit h by 2 is also tending towards 0, and sine of h by 2 by h by 2. Now this have a direct limiting formula, and there's the value is 1. In the next line we can write cos of x into 1, which means it will give cos x, and this is the value of d dx of sin x. Note down this formula. So number 3 formula we get is d dx of sin x equal to cos x. Right? Now we have to deduce more formulas. This chapter is full of formulas. You need to memorize these things like hell. Don't try to be a robot. Just memorize this in the sense that you know this thing, you understand these things. Now, number 4. If this function is given cos x, अभी sin x तो आ गया, अभी बाकी क्या रहा है cos x. Now, cos x. we need to find out f dash x, which means this time I will write directly. H tends to 0 and cos of x plus h minus cos of x by h. So limit h tends to 0, cos c minus cos d will have 2 sin c plus d, 2x plus h by 2, and d minus c, remember d minus c, which means x minus h by 2 by h, which is limit of h tends to 0 to sin of x plus h by 2. We can write this thing, and here we have minus h by 2 by h. Okay, now find limit of h tends to 0, and we have here a sin of x plus h by 2, and just divide the numerator and denominator by 2. Then we have h by 2 sin of minus h by 2 by h by 2. This 2 comes here. Now this is in multiplied form. So plug in this h here. What we will have is sin x into. Here is minus 1. No. Now in the limit problems, what we used to do is to bring this minus sign out of the limit. Right? Now we are bringing this minus sign 1. Minus 1 is out of the limit. Now if h tending towards 0, then h by 2 is also tending towards 0, which means limit of h by 2 tending towards 0, and again sin of h by 2 by h by 2, and that is equal to minus of sin x, which is obviously ddx of cos x. Note the fourth formula down. ddx of cos x will be minus sin x. Now, for the fifth formula, we will not derive this formula. First we will solve some problems that is related to these four formulas. Okay? And then we'll find out the fourth formula. Okay? Now, let's say we are given a function f of x cubed plus x to the power 5 plus x to the power 3 by 2, okay, plus, suppose you given minus 3 x to the power minus 2, suppose. Now you have to find f dash x. What will you find f dash x? F dash x means ddx of this whole term, x cubed plus x to the power 5 plus x to the power 3 by 2 minus 3x to the power minus 2. Now you can separate this derivative in the plus and minus. That means it is associative. ddx of x cubed plus ddx of x to the power 5 you can write, and then you can write ddx of x to the power 3 by 2, and then minus 3. Now remember, whenever there is a constant in multiplied form with some variable, then we bring this constant out of the differentiable. Now this, suppose you have ddx of x to the power n as n into x to the power n minus 1. Now n is acting as 3, where n is equal to 3 you can write. So in the formula if we apply, we have 3 into x to the power 3 minus 1, that is 2, plus ddx of x to the power 5 minus 5 x to the power 5 minus 1 minus 4. Right? Let us write it. 4 plus x to the power 3 by 2. 3 by 2. Bring it down. Then x to the power 3 by 2 minus 1, which means half. Minus 3 is out. Perfect. Then minus 2. Bring it down, minus 2. And then x to the power minus 2 minus 1. The final result will give you 3x square plus 5x to the power 4 plus 3 by 2 x to the power half plus 3 to the 6 x to the power minus 3. Perfect or not? Now, in some problems, you may be given that find this thing, f dash of 1. Suppose the value of 1. f dash at 1. Now, then you have to find f dash x first and then put the value, substitute the value of x with x is equal to 1, like I am here doing. So 3 into 1 square plus 5 into 1 to the power 4 plus 3 by 2 into 1 to the power half plus 6 into 1 to the power minus 3, which will give you 3 plus 5 plus 3 by 2 plus 6. 6 plus 5, 11, 3, 14 plus 3 by 2, which you get 28, and plus 3, 31 divided by 2. Right? In this way you can solve all the polynomial functions. Now, suppose you are given a function f of x where it is given as x square plus sin x. Now what can be done here? Again, apply the similar thing. F dash x is equal to d dx of, first you will do x square and then plus d dx of sin x. We know x square is 2x plus and sin x is cos x. Hence solve. In this way, we are going to solve the problems. The very most important thing in this session is that note down the formulas. Now these are the very basic formulas you need to memorize. The next formulas we are going to come is that suppose we have a function f of x is equal to log of x. Now we have to calculate f dash x. Now again, I will not write the definition. The limit is 10 to 0 and I have f of x plus h minus of f of x by h, which means this will give limit h tends to 0 and f of x plus h means log of x plus h minus f of x minus log x by h. Cool. Now limit h tends to 0 by h, no. Now log, so we have this formula, no, strange formula, where x plus h by x. Now notice, the very thing you need to notice is that when f of x is log x, this is a defined, that is continuous function, then this is obviously, there is the domain of this function, x is not is equal to 0, or you can write x is greater than 0. This comes with the definition of log x, because x, the domain consists of all the positive real numbers, or you can say r plus. Why I have said this thing? We will look it down. We will look, see, what we have is limit h tends to 0, no? Now, see, log of 1 plus h by x, h. Good. Suppose, say, if I put h by x as u, h by x as u, right? Then what is h? ux, okay? Then when h is tending towards 0, then u is tending towards 0, obviously. Now substitute this h by x as u and h as what? Here h will be ux because we are putting here h, but here it will be the variable, which means u. Limit of u tending towards 0 log of 1 plus h by x means u, and h will be u into x. Okay, now this x does not comes to play in this question. This x into u by log of 1 plus u, right? So what we have is 1 by x into 1. This is nothing but the differentiation of log of x, right? Note it down, this formula. This is one of the very important formula. So we got another formula, and that is dgx of log x is equal to 1 by x. Now, number 6 formula, we should look gdx of e to the power x. What do we get? Let's let's see. Suppose we have a function f of x is equal to e to the power x. Then if we need to calculate the f of x, again follow the similar algorithm. First write limit of h tending towards 0, then it is f of x plus h minus f of x by h, which will give you limit h tending towards 0, and f of x plus h means e to the power x plus h minus e to the power x by h. Or you have limit h tends to 0, and you take e to the power x as common, and then you have e to the power h minus 1 by h, right? You have this term, no? This e to the power h. Perfect. Now the thing is, we need to calculate e to the power x. Now put this e to the power x out of this limit. What we have is this term. Then this term is very popular in limit. We have e to the power x. That means, see, this e to the power x, if we derive it, we get e to the power x. Right? Okay. Now, we have got another formula, right? Now it's time for other formula, or another formula. Suppose number 7, g dx of a to the power x. Okay, we'll derive this formula. Now, it's given in the situation that f of x is a function of a to the power x. Now, if we are calculating f of x, then we will write limit of h tending towards 0, a to the power x plus h minus a to the power x by h, right? Okay. Now, let us take this a to the power x out of this term. A to the power h minus 1 will be there, and h will be here, right? Let us take a to the power x limit h tends to 0, and a to the power h minus 1 by h. Perfect. Now, see, a to the power x. Now, this term is also famous in limit, because this term result as logarithm of a to the base e. Now, remember, when log is written without any base, then obviously automatically the base becomes e. Now, if it's written with the base 10, then obviously it's the base 10. Now, further we also write logarithm with base as ln x. Sorry, if log is written like this, log, then the base is 10. Okay, then ln x is written when the base will be e. We have these 7 formulas, no? Number 7 is this one. A to the power x log a to the base e. Now this is the number 7 formula. This chapter have whole bunch of formulas. Even we didn't derive ddx of sec x, cosec x, tan x, cot x. We will derive it later on when we will learn about how to differentiate between two functions which are in multiplication form or which are in division form in the later on classes. Now let's say you are having a function f of x is equal to x to the power minus 2 plus cos x plus 2 to the power x. Okay? Here. A can be any number. A belongs to a real number. Right? A can be any number. Just remember this thing. So, cos x plus 2 to the power x, suppose, and e to the power x again. Now, let us solve it. Or you can have 2 minus 2 log x. Now what we will do is apply all the stuffs, all the formulas here. Now f dash x is given as g dx of this whole thing, x to the power minus 2 plus cos x plus 2 to the power x plus e to the power x minus 2 log x, right? Okay, now we have, remember, this a is not belonging to real number. This a will be a positive number, this term a. Now ddx of x to the power minus 2. Earlier it was a mistake when I said that a belongs to real number. Actually a belongs to the positive number, because if a is negative number, then this logarithm of a will not exist, which means the derivative is not possible. Now ddx of x square, coming back to the business, ddx of x square, sorry, x to the power minus 2 plus, again you have to write ddx of cos x plus ddx of, what is there, 2 to the power x, fine, plus ddx of e to the power x minus 2. Take this 2 out of this term, ddx of log x. Now apply formula only, minus 2 x to the power minus 3 plus cos x means minus sin x plus 2 to the power x log 2 to the base e. Then here it will be as it is, e to the power x, and here it will be 2x. So you can write it like this. So this is the differentiation result. After this video, at the end of this video, we have seen some basic formulas of derivative. Now remember this seventh formula, that a is a positive number, and also the thing is that we have derived some basic formulas. In the next later on videos we will see some more complex things, right? For today, bye, see you, and happy learning.